There are in fact many more applications we can talk about. But you might be wondering already, okay, but what exactly is NLP and what exactly can we do with it? So, what is NLP? NLP contains three words: natural, language, and processing. Natural means we don't look at any type of language, but language from human communication, including dialogues and written text. We do not consider other languages like programming languages. And language, well, you know what language is. It's science with meanings from a linguistic perspective. We can have different signs in different languages to express the same meaning. Now you might be wondering, why do we care so much about natural language? An immediate reason you can think of is, well, it's a means of human communication. Exactly, language is the basis of human communication and interaction, hence the basis to achieve shared goals of communities and societies. That means if machines can understand and speak natural language, we can integrate it into our societal activities for human interaction with no barrier, such that machines can participate in our activities to better achieve societal goals. You have seen examples of intelligent assistants and search engines that have already largely expanded our ability in accessing information and knowledge. Another important reason of looking at natural language is that language affects how human brains produce rational thought and behavior. Note that language is not thought, they are not equivalent. Language is a way of expressing thoughts. But in linguistics, there is this well-known theory called Sapir-Whorf hypothesis, saying that language systematically influences how one perceives and conceptualizes the world. If that's the case, then language provides a means to proactively affect society. This brings lots of opportunities and also risks that we should be aware of while deploying NLP applications. Now let's continue with the definition of natural language processing. Processing means that NLP concerns with computational methods that allow computers to deal with natural language. And with computers comes scalability, which allows us to process large amounts of text automatically and fast. Often the case, we use NLP to perform information need tasks. That is, to satisfy users' needs in finding certain information. We will soon talk about some typical NLP tasks, but before that, let me use a few slides to illustrate why it is so challenging to deal with natural language, and especially with computers. In other words, what qualifies NLP as a major branch of artificial intelligence. You may already infer from the previous slide the complexity of NLP since it has something to do with human thought and cognition, but let's make this more clear using some examples. NLP systems are designed mainly to handle ambiguities of language, which is the main reason why NLP is hard. Here are some examples of real news headlines. If you look at the first example, teacher strikes idle kids. How would you read this sentence? There are two interpretations. One is, teacher strikes those kids who are idle, and the other is, the strikes of teachers make kids idle. Two completely different meanings, right? This has something to do with how we interpret the syntax. Basically, how we assemble words into phrases and sentences. The second example, hospitals are sued by 7-foot doctors. You can either read it as, well, 7 doctors are suing the hospital, or doctors who are 7 foot in height are suing the hospitals. This again has something to do with syntax. Either we put together 7 with foot or foot with doctors. Now, read the third sentence. Red tape holds up new bridges. Here you can read it literally, as in red-colored tape support new bridges, for example in construction. Or bureaucratic red tape delays the construction of new bridges. This has something to do with meanings. Namely, the word red tape has two meanings. Same for the phrase holds up. This is what we call semantic ambiguity. Now let's take a look at the last example, local high school dropouts cut in half. This you can either interpret as dropout students are cut in half, which is a horrible story, or the number of dropouts is cut in half, which is good. Here the word dropout can either mean students or number of students, leading to completely different interpretations of the sentence. Now we have seen how syntactic and semantic ambiguity affects our interpretation of language. Corresponding to this, in a typical NLP pipeline, we often have those two components for syntactic and semantic analysis. Let me briefly introduce what we usually do in these two types of analysis. Syntactic analysis mainly deals with finding out which words should go together. In fact, the word syntax comes from the Greek word coordination, meaning the way things are arranged together. In a syntactic analysis, the two main tasks are part-of-speech tagging and parsing. Part-of-speech tags refer to the roles words play in sentences, namely verbs, nouns, adjectives, and etc. And part-of-speech tagging is a task that determines each word what its part of speech is in the text. Why do we care about this? Well, with the word playing different roles, the meaning of the sentence changes. This we can see from earlier example, teacher strikes idle kids. The two interpretation of this sentence ties to the two different roles of the word strikes. Same to the two roles of the word idle. The other task, parsing, is more closely related to the nature of syntactic analysis. The goal is to determine which words should go together. Now reconsider the phrase 7-foot doctor, whether the word 7 goes with foot or with doctors gives completely different interpretations. On the right hand, you can see a similar example, tea-colored doghouse. The phrase tea-color can refer to either the dog or the doghouse, and determining which words are more closely related is exactly what we do with parsing. We have seen examples where different syntactic structures can be all possible for a sentence, but some of them might make less sense than the others. Take a look at the two sentences on the slide. The first sentence says, the children ate the cake with spoon, and the second sentence says, the children ate the cake with frosting. These two sentences can have the exactly same syntactic structures, but which makes better sense is different for the two sentences. For the first one, it makes more sense that with spoon modifies the word ate, while in the second sentence, with frosting should go together with cake. This example gives us an idea that if we know the meaning of words or phrases, the interpretation of a sentence can be quite clear even with some syntactic ambiguity. The analysis of word meaning or word senses is what we do with semantic analysis. For example, words that look the same can have distinct meanings. This is what we call homonyms. For example, the word bass means a musical instrument, and the word bass with the same form means a type of fish. Another example of what we care in semantic analysis is synonyms, those words that have different forms but with the same meaning. For example, couch and sofa. There are many other types of word relations, hypernyms, hyponyms, which we do not introduce in detail here.